Hello everybody, welcome back to a new challenge of the page Adventjs.dev. In this case, we are in the challenge number 10, which is a medium level challenge. So let's read through the instructions so we can understand what we need to do. So the elf programmers are creating a small magical assembler to control the machines in Santa Claus's workshop. To assist them, we will implement a simple interpreter that supports the following magical instructions. So we can have move x, y that copies the value x, that can be a number or the content of a register, into register y. Inc x increments the content of register x by 1, the x do basically the opposite. And lastly, we have jnpxy says that says if the value in a register x is 0, then jumps to the instruction at index y and continues executing the program from there. The expected behavior are the followings. If an attempt is made to access, increment, or decrement a register that have not been initialized, the default value 0 will be used. The jump with JMP is absolute and goes to the exact index indicated by Y. Upon completion, the program should return the content of register A. If A did not have a defined value, it returns undefined. Okay, so we have here an example of how the instructions works. This is basically the array of the instructions. This is the execution of the compile function, and the result is 2. So this is basically the explanation. This is the step-by-step execution, as you can see here. Let me see if I can zoom it a little bit. Hopefully you can see the zoom. Okay, so in the first instruction, we have move -1 and C is basically the register C receives the value -1. Then the register C becomes 0. Okay, and now as C is 0, then jumps to the instruction at index 1, which is this one. And in this instruction, the register C now becomes 1, and as C is 1, the instruction is ignored, and it continues with the next one, which is move C into register A. So copies register C to A, and now the register A is 1, and finally it increments its value by 1. So the final result is 2, which is the value of the register A. So as you can see here, the expected value of this function should be the value of the register A. So I think we can initialize a register object, and what we need to return is the register A, right? Oh yeah, I think that's okay, because we can use the dot, but I think this looks better. Okay, so now we need to control yeah, we need to have an instruction map, let's say, so we can know what does each command, let's say each instruction, right? So the commands, let's say, that we can have are move, inc, dec, and jmp. Okay, so let's define the first one, which is move, let's say. or MOV. It receives, as you can see, two values. The first one is it could be whether a number or the content of a register. And the next parameter is a register. Okay? So let's define that. It will be a function, basically. Function. The first value, as I said, is a number of registers. So let's call it value or register. Then the second one is the register. Okay. So I think we need to detect or we need to check if the value is a number or a register. So for that, I think we can use, I don't know, a simple function. Well, let's define it here. So let's check um, if it is a register. It is a register that's gonna be the name of our constant. And to check if it is a register, I think we can use the isNum function and pass the value or register. So if that is true, well, basically we can leave it as it is because it will return a Boolean value. So I think that's okay. So if it is a register, then it means it will be a letter. It could be C, B, or whatever letter we receive. So now we need to know the value, right? The value of the first parameter. Okay, so if it is a register, we need to return the register that, let's say, value or register. That in this case, we are sure that it is a letter, A, B, C, or whatever. So let's imagine I received the letter C. As you can see, this gonna be something like this, right? And this will be equal to undefined. Okay. So as you can see, we have a note here at the bottom that says register that have not been previously initialized are initialized to 0. So if this is undefined, we need to initialize it by 0. So we can do this. I don't remember the name of this operator, but this basically means if this is undefined, false, or null, it will assign the other value that we are going to assign, which is 0. Otherwise, we need to use the value that comes from the parameter. Okay. So now that we have that, so if you see here, we need to copy the value into the register. Okay. So the register will be equal to register. Actually, is the other way around. Is register will be equal to value. That's it. Okay. So I think we are done with the first let's say command or instruction. So let's continue with the next one. That will be ink, and it will be a function as well. And the first parameter will be basically the register that we need to increment its value by 1. So let's see. I think we need to check if the register has a defined value. So for that, I think we need to reuse this code over here, and instead of using, well, let me think. Okay, in this case, this is gonna be a letter, right? So register will be something like this, register. And let's call this as register letter, I don't know, or register name. And this is the register, which is our object over here. So if that register name is not a number, then we need to initialize that um, um, by zero, with the number zero. Actually, let me think if we are doing this correctly. So if it is a register, if it is a register, then okay, it should be not a number because it will be a letter. Okay, I think that's okay. Okay. Otherwise, okay, basically, I think we need to do something like this actually, because this this will always be a register, the name of a register. So we need only to know or to get the value of that register, and if doesn't exist, we need to initialize it with zero. Okay, or initialize to zero, I mean. So now that we have that value, we need to increment the value of that register. So the register, that name will we need to increase their value by 1. And we need to do basically the same thing over here, but with deck. And instead of increasing the value, we need to decrease it. And finally, we have a JMP, which is a function as well, and it will receive, let's see, okay, it will receive the value because it says if the value in register X is 0, okay, actually it will be a register name, okay, register name. And the second parameter will be the index where we need to jump into the instruction, So it will be instruction index, let's say. Okay, I think we need to do something like this as well. Okay, in this code over here, I think we need to do something like register name will be equal to value and minus, well, plus 1 in this case, minus 1, because we were not defining the value, we just were incrementing or decreasing the value. But if it was, let's imagine, undefined, and we decrease the value of undefined, I don't know, but I think it will cause an error. So that's why I am assigning the value and then incrementing it by 1 or decreasing it by 1 in those functions over here. Okay, so okay, so now that we have the value here in the JMP function, we need to check if the value is 0. If that is true, we need to jump to the instruction at the index y, which is the instruction index. So we need to check if the value is equal to 0. Okay, I don't know, let's return the instruction index. So because I think we need to use this later on. So in this case, we need to return a value that it will be, let me think. Well, I don't think we need to return a value over here because we are constantly modifying the register object, and at the end, or yeah, at the end of the function, we will return whatever the register a value is. Okay, so I think we are done, at least with this part of the code. I think we need to do something here. So register will be equal to, I think in this case, we need to do something like this, if I am not mistaken, because the move function receive the value of register, and the second one will always be, I mean, the name of register. So let's rename this to register name, I mean, and this gonna be register, and okay, and register, that register name will be equal to the value. Okay, so now we need to I don't know, maybe use a for loop, or let's use a while loop. Okay, and let's create, I don't know, a variable that it could be the pointer, let's say. So the pointer is like, will indicate at what step is the current assembler, I don't know, the current machine or the current instruction. So obviously it will start by with 0, so it will start from the beginning. Okay, so y pointer is less than the length of the instructions, we will do the following. So let me think. So, okay, first of all, we need to detect, I mean, or check what is the command, what is the, and what are these values, right? As you can see, all the elements within the array will be an string. So I think we can do something like this. We can split that string, for example, instruction, that pointer, that I think it will be split. We will split it on every empty space or white space, like this. So we are splitting them, or we will have the first 3 letters, and then the second parameter, or the first parameter of that instruction, and the second one. So we will have something like the command that could be move inc jmp whatever, and the parameters, and let's call it x and y, because it could be, it can change depending on the name of the command. So now that we have that, I think we can use the instruction map over here, pass the command, and okay, pass the command, and then, well, basically the the parameters. Okay, so as you can see here, none of those functions are returning a value except by the last one that returns a value as long as the value in this case is equal to 0. So let's use this return information, let's say, to know when we need to jump to another instruction index, let's say. Okay, so, well, basically we are going to use or to define a constant here, and let's call it jump index. I don't know how to call it, but hopefully it is clear. If the jump index, let's see, let's modify the pointer, right? So the pointer will be equal to, first of all, we need to use a ternary condition here. So if the jump index is defined, then the pointer will be, we'll get that value of the jump index. Otherwise, we will increment the pointer value by 1. Okay? Well, let's see if this is working. So let's try to understand first before submitting the solution if this makes sense. Okay? So here we are extracting the command and the parameters of that instruction. And then we are using here, here, the instruction map. And it will access to move, ink, deck, or JMP or jump. Okay. For example, in the move instruction, we are basically getting the value of this value or register. And now that we get it, we are assigning that to the new register. Okay, I think that makes sense. Now, in the second one, which is the function in charge of incrementing the value, we are basically getting the register name, accessing to them, and if it is undefined, we are initialize it by 0. I mean the value in this case. And then that register will be equal to the value plus 1, and the same thing over here, but instead of increasing the value, we are decreasing it. And in this case, we are getting the value of the register name, that it could be undefined. And if it is undefined, we are going to assign it to 0, but I don't think so. This is quite right. Let me think. Because if that is not undefined, if that is undefined, I think it's okay to leave it as it is, because the instruction says if the value in register X is 0, then it jumps to the instruction at index Y. So if, let's imagine we are receiving the letter, I don't know, D, and register that D is undefined, I am not sure if we need to initialize it by 0. Well, basically, well, I think so. We need to do it because according to this note, it says the register that have not been previously initialized are initialized to 0. So I think it makes sense to initialize it by zero or with zero in this context as well. So I don't know, let's execute the solution to see what we get. Okay. Okay, so we are getting a string instead of a number. Okay, that makes sense because all the elements within the instructions are a string, so we need to parse it into an integer or a number. So to do that, we need to add a plus character in front of the value to transform it, or we can make it more clearer, make it clearer, I mean, by using the parseInt function. So let's use the parseInt function. Well, I think we need to use it here. ParseInt value. And here we need to use it as well. Here as well. Um, okay, and here as well. Okay, okay, now let's see now what we get. Okay. Okay, in this case, we were expecting -2, but we get undefined. Okay, we are almost done. So let me copy this example here. Well, I cannot copy that. I don't know why. So let's imagine that the instructions are equal to this array. Okay. And we will have move to x. Then we will have deck x, deck x, jump x into 1, and move xa, and let's see. Okay, so according to the last okay, this makes sense. Let me think. So in the first instruction, the x is 2. I am taking a look at this part of the code. The first instruction, the x becomes 2, and then becomes 1, and then becomes 0, and then as this is 0, it jumps to this one and becomes 0, and then becomes -1, and then continue with the next one, but it should be -1. Well, I don't know. But we are getting undefined. Okay? So let's see what we get wrong. So value or register. If it is a register, if it is undefined, we are initialize it by 0. If not, we are using the value. Okay, and the value could be an string, but we are parsing it to an integer over here when assigning the value, right? So this is quite interesting. I don't know what we are, why that is not working. Okay. Maybe register that name, parsing int value -1. I don't know. Let me copy this code over here. And let's use, uh, let's see the log over here. Let me see. Let's use these instructions. And we can use compile, something like this, but in lowercase. And let's see what we get, but this is not working. Okay, I forgot the commas. Okay, let's do it again. Okay, this is undefined. Okay, let's have this. Let's put some console over here. For example, I don't know, maybe here, let's log the register. So to know what we get. And then let's execute the function, and we have, okay, in this one, x is 2, that's okay. It decrements by 1, and then 0, and then in the jump, it's 0, and then it goes to the first one, which is -1, and then -2, and then, okay. So something is not working well when we reach the jump instruction. So let's see what we need wrong, what we got wrong. Yeah, that's weird. So maybe it's something here, pointer, jump index. Okay. Let's also log the pointer. So we have the register and the pointer. Let's see. So 0, 1, 2, 3. Okay, the pointer here is is an string, which is weird. Okay, so we have something wrong in the jump function. Okay, the instruction index should be also an integer. So because this is an string, so we need to parse it as well. So let's see, parsed int, and let's see what we get. Awesome, awesome. So it worked, but unfortunately we get 1 star. So I cannot try. I want I'm not gonna try to improve it because the video is really long, let's say. So I don't want you to get bored with me more than you you are. I think, I don't know. And the thing is that I was thinking of creating a second series of these kind of videos, trying to get in all the challenges the 5 stars, so this is gonna be really challenging for us, or even for me. So I do want to do that because it could be um it will be really nice to do. I think I will enjoy it, and it will be, I think we can learn something new together. Yeah, and that's it. Obviously, this code can be improved even better, even more. So yeah. So let's leave the code, the video until here. Yeah, I will see you in the next video. Thank you for watching me. If you reach to the end of this video, thank you.